start today's experiment. All are able to hear me now? Are you able to hear me or not? Whoever is in the classroom, are you able to hear me or not?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Ma'am, but there's a disturbance, ma'am.
So,
Ma'am, your voice is very low.
today's
Yes, ma'am.
also. So now tell me what is your other today's experiment? Tell me. So far, what are the experiments that you tried out and what is your today's experiment actually as I'm showing here?
Ma'am, you are inaudible.
So just to tell me what is your today's experiment?
Wave shaping circuits.
Okay, today you are going to do wave shaping circuits. So under wave shapers you are to do two sets of circuit configuration, that is you will be trying out rectifiers and strippers you are going to try.
Ma'am, your voice is not audible, ma'am.
Ma'am,
Yes,
can't hear,
ma'am.
ma'am.
Ma'am, there's a disturbance in the
Suppose
background, ma'am.
some of you are able to hear it, able to hear and some people are not able to
No,
hear.
ma'am. Ma'am, it's the
Ma'am, we are.
mic
No,
No,
ma'am.
ma'am. Ma'am,
is
we are
So,
not
far
audible,
from
ma'am.
your.
it's very low, ma'am.
Ma'am, I can only hear you after keeping my speaker on 100, and it makes very loud disturbance in the surrounding.
Okay, what about now?
Yes, ma'am, now it is better.
Now it's echoing, ma'am.
Ma'am, but the same sentence is being repeated.
You are getting ambulance voice, ah, very nice. All are in the happy mood. Okay, what about now? Are you able to hear me?
Yes, ma'am, now it is
Yes,
Yes,
ma'am.
ma'am, it's
completely
audible, ma'am.
perfect.
Yes, ma'am.
Okay, so I'll try to rush it off. Today you are going to discuss two types of circuit configurations with the help of which you will be reshaping the input to a desired output. Okay, usually you are using what type of supply when you are connecting a load or an appliance? What type of supply are you using?
DC.
What supply? AC. AC will be like this,
Yes, ma'am.
isn't it?
AC.
All are able to see the sinusoidal symbol, but
Yes.
I don't want this AC. Suppose if I want to drive mobile phone charger, okay, you know mobile phone charger is
AC.
giving you DC or AC.
DC.
AC, yeah. The
DC.
mobile phone will be using DC battery is
DC.
inside there, so it requires DC supply or AC.
AC,
DC.
ma'am. AC to
It
DC
will
too.
be DC only. So I don't want to have this sinusoidal AC supply. I want to reshape it. So I want to convert this AC to a DC one. So that process is called as what process? Rectification. Okay, and that rectification can be done in two ways. I think you have studied this in your lower classes. So what are the two types of wave shaping rectification?
Half wave and full wave rectifier.
Suppose if this is your input cycle, if I am getting output only for positive half cycles alone, then that type of rectification is called as what rectification?
Half wave. Half wave.
HWR means half wave rectification. But on the other hand, if I am getting DC waveforms, that is pulsating DC for both positive and negative half cycles, then it will be called as what type of rectification? HWR means half wave rectification. FWR means full wave rectification. Okay, the number of the diode arrangement will also differ depending upon whether it is a HWR or a full FWR. So this is one of the wave shapers because you do not want this input as such. Okay, you are reshaping it to a pulsating DC, so that is one of the wave shaper. But on the other hand, suppose if you want to partially clip the waveform, okay, again you consider the input AC, but I don't want the full AC. I want to clip up to some portion. Okay, let this be the V reference value. Up to this portion only I want the waveform. So that is called as what wave shaping circuit?
Ma'am, would you please repeat?
What is the name of the wave shaper? We have discussed rectification. Rectification means conversion of AC to DC.
Clippers.
Suppose if you are having a sinusoidal AC, okay, suppose we are having a sinusoidal AC like this, but I don't want the exact sinusoidal AC. Okay, I want to clip off a partial portion of the waveform alone and then I want to drive the load. So that type of wave shaping is called as what?
Clipper.
Clipping. Clipping, ma'am.
Clipping. Okay, so one more thing is also there. Suppose take the same sinusoidal AC, which is VM. Okay, but I don't want that VM. I want to shift it above some DC value. Let this be 10 volt DC. I want to shift the entire waveform above this DC. Okay, I am adding DC to the AC supply. So if you want to obtain this, okay, this is my AC which is shifted above the DC, then that will be called as what wave shaper? That process is called as what process?
Clamping.
Clamping.
What is the name of the process? We have discussed
Clamping, ma'am.
clamping. Okay, clamping or DC restoration, because we are clamping or DC addition. Okay, we are adding DC to the existing AC. So that type of wave shapers are called as clampers. And there are so many different types of clampers, clippers: positive clipper, negative clipper, biased clipper, unbiased clipper, positive clamper, negative clamper, peak clamper. So many different divisions are there. So for you, only rectifiers and clippers are given in the circuit. Now, have you understood the meaning of the wave shapers? What are wave shapers actually?
The wave shapers are.
What are wave shapers?
They are
Rectifiers
that
and
change the
clippers.
shape of the wave, output wave.
Yes, you do not want the exact shape of the input waveform. You want it to modify it and deliver it to the load. So for that purpose only you will be using a wave shaping circuit. So many different types of wave shapers are there. What are the various wave shaping circuits that you are having? You are having wave shapers, that is rectifier,
And clippers.
then clipper, then clamper. Okay, in order to do all this wave shaping, inside the circuit you will be having LCR component only. Using this combination of elements only, you will be doing the wave shaping. Okay. Now let us first discuss how to do rectification. So this circuit you are seeing, This is actually a half-wave rectifier. Okay, HWR. That is a half-wave rectifier you are having. I've already told you what is the meaning of a half-wave rectifier. So what is a half-wave rectifier? And how many diodes are there in the half-wave rectifier?
Half-wave rectifier
How many diode
erases the
elements?
negative push.
One, ma'am.
One.
One only.
Only one diode is there. Okay, and the input is what supply? Input is single phase 230 volt 50 hertz. That is the AC supply.
AC supply.
Okay, AC supply. What are the two terminals of the AC supply? As usual, P is referring to phase and N is referring to neutral. And what
Neutral.
is this element? This one that I am circling, that is called as what?
Transformer. One
Single phase transformer. So it is a step down type or step up type?
Step down.
Step down.
Step down. So step down ratio is how much?
232.
Step down ratio is how much? 230 to 6. Given 230 AC is converted to 6 volt. And then it is given to a diode. You know the two terminals of the diode are what? A and K. So the anode is connected to positive. The cathode is connected to 0. So this is forward biased or reverse biased at this point? Forward biased or reverse biased? Forward biased. So it will close. Okay, the circuit will be closed.
Yes, ma'am.
So when it is positive cycle, okay, then the diode is closed. So it will deliver the same to the load. Okay, this 1K is the load. So same output will be obtained. But consider the negative half cycle. Okay, the cycle reverses and it undergoes a negative transition. In that case, this diode will become what? Now it is
Reverse
negative
biased.
transition. It will become reverse biased. So this switch will open. It will not be closed. Okay, this part is now open. Okay, open means will it conduct or not conduct?
No, ma'am, it will not.
Open means circuit is closed or not closed?
Not closed.
So will you get the output at this point or no output will be present?
No.
Not closed.
No.
Okay, again consider the cycle is transiting the positive half cycle. Then it will close. Okay, again it will deliver the output. During the negative half cycle, again there will be zero output. Like that, it will go on. So this is how, what type of rectification is achieved here?
Half wave.
Half wave, half.
Half wave, ma'am.
What type of rectification is this?
Half wave.
Half wave. What is half wave? What is half wave rectification?
Only one side of
What is half wave rectification? What
Only
is half
positive
wave
part of wave.
rectification?
only positive part of wave will be present.
In one
The
side.
negative part will be erased.
Only during positive half cycle transition, the load
The load will get
will
output.
be supplied.
Yes, ma'am.
How many diodes are you going to use for a half wave rectifier?
One.
One.
How many
Only
diodes
one.
will you use?
One.
Only one.
Only one. But there is one capacitor. Are you
Yes,
are you
ma'am.
are you observing?
Yes, ma'am.
Are you observing one capacitor here? This
Yes, ma'am.
capacitor. See, without that
Yes, ma'am.
without that capacitor also you can use. Okay, that way it will be without filter.
Yes, ma'am.
Okay, suppose if you are including that, okay, if you are including that into the system, then it will be with filter. Okay, if you are including the capacitor here, then it will be with the filter. So what is the use of a filter here?
To supply the
Filtering.
supply the
You
load.
can see to these waveforms.
Yes,
Three
ma'am.
waveforms are there. Okay, this is what waveform that I am showing. First waveform that you are having,
Full
this
wave.
is referred to
Yeah,
what
normal,
voltage?
without rectifier.
That is a sinusoidal
Yes,
input that
sinusoidal.
is rated 6
Yes,
volt. Okay, 6 volt. This is input. Okay. And
Yes,
this
ma'am.
is your output without capacitor. That is without filter. That is your pulsating DC. Okay, but I want pure DC. Okay, unidirectional DC. Unidirectional DC will be like this. So I want to avoid the ripple. Ripple means unwanted DC in AC. Okay, AC in DC, that is called as ripple. I want to avoid that ripple. Okay, so in order to do that, I am adding one capacitor. That capacitor will act like a filter. So if I am doing that, you will be getting a third set of waveform. So this part that I am following, that will be the output that I will be getting. If you are adding up what here into the system,
Filter.
both are outputs. Okay, this is here only capacitor is there, here no capacitor. Okay, so if you are adding a capacitor, as you can see by the waveform that I am following, it is almost straight line or not straight line, pulsating. Which one is the
Almost
case?
straight line.
Here it will be pulsating. Okay, almost straight line. So the ripple's presence is taken care by the presence of the capacitor in the system. Okay, so this is a circuit that you are going to first simulate, and using the waveforms that you are getting, you have to tabulate all these things in the table. What is VM? You know how to find out the VM value, that is the peak value. Then using formula how to calculate VRMS, you know. Okay, and the ripple factor, there are some formula that is given in the manual, I think so. Are you having formula? Are you observing? There are some formulas, no? Okay, so using this formula, you have to tabulate all those values in the tabular column, both for with filter and without filter. You cross-check these answers with the formula that is given in the book. Last time there was some mistake in the formula. I will also do cross-check. Okay, but you have to use all these formulae to calculate all the things and tabulate it. Both the values should match. Okay, alright. This is all about half-wave rectifier. You have to draw the waveform again. Now if you see to this diagram, what can you observe? What changes can you observe here?
Two diodes.
Two diodes. Okay. So this circuit will act like a FWR, that is a full wave rectifier. Again, same way you are having a single phase 230/50 Hz AC supply that is being stepped down to 6 volt. So here you will be having 6 volt, here you will be having 6 volt. This is a center tapped transformer. Okay, this is center tapping that you are having. So that is a center tapped transformer with the help of which you are getting 6 volt, 6 volt. Now, if this is passing through positive half cycle, this diode will close. Okay, but at the same time, this will be negative. Okay, this will be negative. So this will be open. Alright. So if the supply is positive, then because of the conduction of this diode, it is on. So automatically output side you will be getting load connected to the input. Now second case, when the input is going through a negative transition, okay, negative transition, then this diode will become off. It will be open and this diode will conduct. And because of this is because of D1, this is because of D2. You will be having again one output current delivered to the load. Again, during the positive half cycle, this diode will close and this diode will open, because of which again load will be connected to the input like that. Okay, so this is how you are getting what type of rectification?
Full wave.
What type of rectification? This is full wave rectification.
Full wave
so when the
rectifier.
diode, one of the diode is on,
Full wave.
yes, if this diode D1 is on, means this diode D2 will be off. If the diode D1 is off, means this diode D2 will be on. So alternatively, these both will be coming into conduction, so that for all the positive and negative half cycles, you will be continuously getting the pulsating DC. Okay, both positive and negative half cycle, you will be getting the output across the load. And here also you have to discuss what will happen to the output with and without presence of the capacitor here, that is your filter. So let us discuss that with the waveform. So what waveform is present first? As usual, this is your input supply, and the second waveform is your output without capacitor or with the capacitor.
With
Without
without capacitor.
Without capacitors. Without capacitor. Capacitor is not present, so this is a ripple DC. Okay, but I don't want the ripple here, so I will be adding the capacitor here. So with the capacitor, with the filter, the output will be like this. This is my output. Okay, as I have marked in the red color line, that is my output without filter. Again, you have to use the formula, the set of formula to calculate VRMS, VM, VDC, ripple factor and efficiency. Okay, so this is all about rectifier. Next wave shaper is clipper that you have to discuss. So what is a clipper that I have told you? What is clipper?
Only a portion of sinusoidal wave will be taken.
Yes, I want a desired portion of the input, so I want to clip the undesirable portion, so that can be done by using a clipping circuit. So there are so many types of clippers that you are having. Okay, so the different types are biased, unbiased, okay, and both categories will be having positive and negative. Positive and negative clipping. Okay, so these are the different types of clippers that are possible. Now we will tell you what is positive clipping and what is negative clipping. So if you see to this waveform, so this is my input waveform. So what portion is clipped actually?
The positive
The
portion.
positive portion is clipped.
Positive.
Positive portion. So this clipper will be called as positive clipper. Okay. And if you see to the circuit, I am using what here? What is
DC
used?
source.
DC source.
Voltage.
Yes, DC source.
Battery.
So this will be providing V reference, that is bias. Okay. So in this is the input waveform. Okay. I am drawing the VDC value that is given by this RPS. Let it be 2 volt. So whatever may be the portions that are greater than 2 volt, those portions are clipped. Okay. So this way, if you are giving a clipper, then that will be called as biased positive clipper. Okay, biased positive clipper. But on the other hand, if I am not using a V reference, okay, I am not using a V reference, simply a diode I am using, then it will be called as an unbiased clipper. Okay, positive clipper, both are positive clipper. Understood the difference between biasing and unbiasing?
Ma'am, wouldn't the unbiased almost make it a half wave kind of?
Yes, yes, yes. Because in that case, V reference will be 0 only. So half wave only, you are correct only. Now if you see to the circuit, again you can see an RPS here. So this is a biased clipper or unbiased clipper again?
Biased.
Biased. So that value V reference that is given by the bias, let it be 5 volt. Okay, so this is your 5 volt that is contributed by the RPS. Now what portion of the waveform is clipped here? Less than V reference.
Negative.
Is clipped. So what portions are clipped? This is a negative clipper. Understood the difference between biased, unbiased, negative and the positive clipping? All of you in class, have you understood the wave shapers, the different wave shapers? I want answers from everybody. Have you understood what is clipper? Rectifier? Come on, only from your answers I'll proceed to the E-circuit part. Okay. You people understood, huh?
Yes, ma'am.
Yes, ma'am.
Okay, I will stop presenting from this device, sir. But you people understood what are the different types of wave shapers, how to proceed with them.
Yes, ma'am. Yes,
Because
ma'am.
the same topic will come in theory part also. Okay, while it is coming in theory, I will not discuss this thing in detail. I will give you only a short description only. Okay. So I will stop presenting from over here. We will move on to E-circuit now. All are in E-circuit. You know how to open E-circuit as usual. Okay. Now as usual, I will open a blank circuit. You know how to open a blank circuit. So I am using a blank circuit. Alright. Now first circuit that I am going to try is half wave rectifier. So tell me what are the various components that are required using the manual. All
Ma'am, are you talking, ma'am? I cannot hear you.
No.
Thank you.
Oh, why ma'am has a reduce mark in the experiment too? Oh, sorry, it is recording.
You might have done some mistakes in calculation.
Open the edited file. You'll know where exactly she has reduced marks.
Yeah, I'm just seeing.
How to open it?
She has attached in the GCR
Oh,
edited file.
Where did ma'am go?
see you people are able to hear me out or
Yes,
not.
ma'am.
Yes, ma'am.
Yes, ma'am.
ma'am, now we can
Okay,
hear you.
all have opened the E-circuit, blank circuit, huh?
Ma'am, till this time we were not able to hear you.
All are able to see the E-circuit screen.
Yes, ma'am.
Yes, ma'am.
Okay, what are the various components that are required for framing the half-wave rectifier?
Ma'am, there's two
You
inductors.
have to have one
Ma'am, AC
input
source.
AC source. So I have connected that input AC source. Then I have to have a transformer.
Ma'am, two inductors.
Add a transformer. Transformer is directly present, so you
Okay,
add a
ma'am.
transformer. Okay, like this. Alright. Then next thing is you need to have a diode.
Diode.
Okay. Add diode. Okay. Next, without filter, first we will try. Okay. So don't add a capacitor. Only resistor you can add. So I have assembled all the components. All are assembled in the same way. All
Yes,
these
ma'am.
components. Now I am trying the circuit without filter. Now time to edit all the components. So the input supply that is given is 230 volt, 50 hertz. So I am changing it to 230 volt, 50 hertz. The standard AC supply. So I am giving 230 volt, 50 hertz. Then if you want to edit, keep the default values as such. Okay, let me see what happens here. Alright. Then what is the load resistance that is given in the problem?
230, ma'am.
Ma'am, your voice is breaking.
Manual
We
1K.
can't hear you, ma'am.
So keep that as the components. See, here it is raining. Alright. So maybe. Anyway, even if you are not able to hear me, you can see the screen. You can do
Yes,
the
yes, ma'am.
assembly that
Yes,
you
ma'am.
already know. Don't depend upon
Ma'am,
my
what is the
voice
third component,
always.
ma'am? I forgot. Where is it? No.
Diode.
Diode, PN junction.
Oh, normal diode.
Huh? Active diode you have to select from active component now. Even if I am not audible, you try the circuit all on your own. I have given enough explanation. Okay, so as you can see, the conventional current flow is okay. Now just I want to see the waveform alone. I have to know what is the nature of the input, what is the stepped down voltage, and what is the output voltage. Three waveforms I will check it out. Waveforms that I would love to check. That is the input waveform, the output waveform. Without waveform here I want to know. Then the waveform that is obtained as an output from the step down transformer I want to know. And the waveform obtained across this 1K I want to know. Okay. So I will check viewing scope and I will check. I think already it is viewing scope. All are able to see the waveforms that I am showing? Okay?
Ma'am,
One
something
is
is going wrong
input
with my
waveform.
diagram. Ma'am.
Yes, ma'am.
What did you do?
No, ma'am, I
Only
don't.
if you show, then only.
Ma'am, can I just present my screen?
What?
Can I present my screen?
Wait. Yeah, you present. See, all the others you have to get the waveforms that I am showing displayed. Okay?
Yes, ma'am.
You can see only positive half cycle waveform is coming, or both cycles you are getting waveform.
Only
Start
positive.
presenting now.
Who is presenting now?
Ma'am, I'm
Somebody
presenting.
was having doubt to know.
Yes, ma'am, I'm presenting. Rahul, 148. Ma'am, why is my convention? Why is it like this, ma'am, for me?
Is
50
your what?
hertz. No, ma'am, if you see, mine is moving way faster, even though the resistance are the same. 50 hertz, 230 volt. Then transformer, diode, and resistance 1K, ma'am. But my current way faster. Is it wrong? What I've done? Have I done? Made a mistake? No. Hello, ma'am.
You show the waveform. You put view in. I think it's correct. View in scope you give. Form and give view in okay, scope. But you show the output wave. I think yours is correct only. You show the waveform. View in scope.
Okay, ma'am. Thank you, ma'am.
But you show the
I'll stop.
waveform. And then
Oh,
if it's
1 second,
presenting.
ma'am. I'll present my screen. Sorry, ma'am. I closed it. How is the waveform?
See, and one more thing, you people.
Yes, ma'am.
See, one more thing. You are seeing that these things that are displayed at the top bottom corner. No. Are you able to see the top bottom corner value?
No.
No, ma'am.
See, Rahul, are you going to present or shall I present, man?
चालेल तुम्ही पडून घ्या ना म्हणजे तुम्हाला झोपत असेल
Yashwant.
Okay, then I am presenting. Okay. The rest in class, are you able to follow or not?
नो मॅम
I think I lost my internet connection. Wait. My connection is lost. Wait. Till I reconnect.
ओके मी ऑल्सो प्लीज शेअर दिस व्हिडिओ ऑल्सो
कौन है host? Host कौन है?
मॅम ओनली
Is ma'am the host?
येस
Oh,
येस
ma'am
येस
is the host. It's raining heavily here. That's why.
See, you people are able to see the screen that I am presenting now.
No, ma'am.
Wait. Now it will come up.
येस
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
See, at the bottom top corner, bottom corner, you are able to see the RMS value, VM, VDC, everything, no? Yes or no?
Yes, ma'am.
येस
Okay, that you have to note it down, but not for the input voltage, but for the output from the transformer you have to note down. So include one more waveform also. The output from the primary transformer you have to include. Okay, let me see what about this waveform.
and we need to put the ratio
How much stepped down you have to indicate?
230:6
That will not be 6 because I have used the default value. Okay. So I will stop viewing everything. Wait.
అలాగే ఉందంట.
See, people, if you're not going to talk, you mute your mic. So much background talk from your parents or somebody is there.
Reddy, Reddy, mute your mic.
Ready?
The one who is host, please mute him.
Yashwant.
Who is host, please mute him.
Yashwant, mute your mic.
The one
I
who is
think he
host, please
kept it
mute
where
him.
somewhere.
Someone call him. Someone call him.
Arey, no, the host can. Who's the host? Ma'am, you can mute him,
Ma'am will
ma'am.
be the host, na?
Ma'am, you can mute him, ma'am.
Ma'am is the host. You can
Whose
mute
mic
him.
is open actually?
Ma'am, Mita
Mita
Yashwant.
Yashwant
Yashwant
Reddy.
Reddy.
Vitasa.
Yes, ma'am. See, ma'am,
Yeah,
there,
this
blue.
ma'am.
Ma'am,
Ma'am, it is upwards. It was upwards.
ma'am, not me, ma'am.
Mute Tambali. Mute.
Sometimes if I try to mute, it will not mute. Vita?
You can remove it.
Madam,
Ma'am,
he
now
went
the
somewhere
options
else,
have
madam.
changed. Ma'am, you have to click that.
Yeah, mute.
Okay.
Yeah, done.
Alright, I've muted. Alright. See, now you people listen to me. I think all are able to understand what I am trying to do here. Or otherwise, if you don't want 230 means, here itself you change it to 6 volt. Because I am not able to check the output of the transformer properly, so I am changing it to 6 volt. Okay. That way it will be easy for me. And I will try to view it in scope. Okay. So this you do, okay, put that AC voltage 6, okay. I think, I don't know how this transformer works out. What step down value it gives, I am not able to check it out properly. It's showing nanovolt or picovolt. So better change the 50 hertz AC source to 6, okay. Without the transformer also you can use directly, whichever way you wish. Okay, I am disconnecting the transformer. This way also you can use, okay. Both are one and the same only. I think two bad connections are there, that I will eliminate. Okay, this way also you can try, without a transformer also you can try. Understood, huh? Yes or no? Okay? Because I am not able to check out what value it actually steps down, so I am eliminating the transformer there because there is no necessity of center tapping. Okay? So at the bottom side you are having all the RMS, VM, everything is getting displayed. So what is Vmax? 6 volt. What is VRMS that it is displaying? What is VRMS it is
4.2 volt.
displaying?
4.2 volt.
4.24. Okay, you can cross check this also, right? Power everything is displaying and the output is also displaying. Okay, so this is all about a half wave rectifier. All of you understood how to proceed with the half wave rectifier, huh?
Yeah, ma'am.
Okay, now what do you need to do? You have to copy the circuit with the waveform. You have to copy both input and output. Then you have to paste it. Okay, this is one circuit. Next, we have to proceed with the full wave. So again, I'm opening
And
a
what is the
blank
input
circuit.
output here?
Input is sinusoidal AC. Output is see. And
Okay,
one
okay,
more
okay.
thing I forgotten to do. With the filter, you have to try now. With
Yes, ma'am.
filter,
With
I have
amplifier.
forgotten to. Let us do that also. What about the rest in class? All of you understood or not? There is no answer from others in
Yes, ma'am.
class.
Yes, ma'am. Got it.
Ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am.
Okay, I will add up one filter also, that is capacitor I will add. And let us check out what happens. 10 for 10 microfarad, what is the value?
Ma'am, it is 100
10
microfarad.
microfarad.
100,
100 or
100.
10?
100, ma'am.
Showing bad connections. So I will connect properly. Okay, so now I have connected a filter. Okay, let me check out. Let me edit the data. I am giving 6 volt here. 50 hertz. 100 microfarad. I think 10 only I
Yes, ma'am.
saw.
Yes, ma'am. 100 only.
Okay, 100. Okay, circuit is done. Now I will see the output waveform. So this is my input. So the Vmax, VRMS value, the DC value, everything is getting displayed. Now I want to check out what happens at the output side. So you can see how the waveforms are there. Are you able to check it out? Is it a pulsating DC or a ripple free DC?
Okay, ma'am.
All are able to observe?
Yes, yes.
ma'am. Yes, ma'am.
So we should paste the screenshots of this circuit or the before one.
This circuit also.
That
Both
means
the
both
circuits
the
you have to copy and paste. Okay. Yes, one with filter, one without filter, half wave
that means
rectifier, then full wave rectifier with filter, without filter.
4.
Okay. And then for full wave rectifier also you have to try the same thing. So all have understood half wave rectifier, ah? Shall I proceed
Yes,
with full
ma'am.
wave?
Yes, ma'am.
Yes.
Okay, I'll proceed for full wave. Again, as usual, I have to add one source. But here I have to have one center tap transformer. Diode here.
Ma'am, there are 4 diodes, no?
That is for a bridge rectifier. I am not doing
Okay.
bridge rectifier, only full wave. Where is the center tapping connected? All are connecting or what? Okay, center tapping is connected to the other end of the resistor. Okay. All are doing connection or what? Answer me.
Yes,
Yes, ma'am.
ma'am.
Doing.
Okay. So now I have connected. Now I have to edit the component values. Let me see what happens. Frequency alone I am changing. This is without filter. Let me see first input. Both the currents and voltages are getting displayed. Okay, small waveform is current. Alright, again you have to note down what is the Vmax, Vrms, DC value and all. This is input. Okay, I think I have given 5 volts. Next, let me see what is the nature of the output. All are able to observe, are you able to observe the load waveform? That is both half cycles you are getting output or no output. Are you able to observe both half cycles at the load side or not?
Yes, ma'am.
Okay, this is without filter or with filter?
Without filter.
With filter.
Without help.
Filter, okay, and check out. This circuit you have to copy and paste without filter, okay. Now I am adding on capacitor and I am checking out what happens here. Okay. Come on, all are able to see the waveform?
Yes, ma'am.
Yes,
Now
yes.
it is ripple free DC or with ripple? That full
Ripple,
half
ma'am.
cycle it is not present. Okay, it's ripple free DC. Okay,
Yes.
alright. Okay, so 4 circuits you have to copy and paste. One half wave rectifier with filter without filter. Full wave rectifier with filter without filter. All have understood up to this. Shall we move on to clipper part?
Yes,
Okay,
ma'am.
ma'am.
Yes, ma'am.
The rest in class, do you want me to name you and call you for asking whether you understood or not?
No, ma'am.
No, ma'am.
Come on, Roshan, Aryan, Ayush, Aditya, Agarwal, Srish, Dhanush, Ella, Sai
Yes, ma'am.
Pritam,
Yes, ma'am.
the girls, Tejaswani, Vishesh, Varun, Vaibhav, Samyukta, Nagaseni, Reshma. All of you understood?
Ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, shall
Yes.
we proceed to the clipper part then?
Yes, ma'am.
Why Roshan is telling no, ma'am? He did not understand.
Ma'am, he was answering for your voice. You were asking, ma'am.
Okay, so we will proceed to that clipper part then. You're okay with it? Okay, now we'll move on to clipper. Again, I'm opening a blank circuit. As usual, AC supply will take it. Then what are the other components that are required? One resistor of 10K, then a diode. Okay, let us check out what happens without biasing. Okay, first. Then we will add bias and then we will check out. Okay? Okay or not?
Yes, ma'am.
Yes, ma'am.
Okay, I am not going to add bias. Okay. Alright. Okay, so this is without bias where V reference is 0. So now I will give some values also here. I am giving 10 volt or something and I am fixing 50 hertz. Okay, and I am changing the resistor value to 10K. Okay, now I will observe the waveform, that's all. First, starting with the input waveform. So you can see for yourself the input voltage is green color, the current is yellow color. Okay, both are displaying underneath. That is a full sinusoidal waveform. Let us see what happens across the diode output waveform. Okay. So are you able to see which portion is clipped there? How the clipping happens between input and output, all are able to see? Yes or no? So here you are having full waveform, but here what portions are clipped here? Positive portions are clipped or negative?
Positive.
So this is unbiased clipper or biased clipper? Unbiased. Okay, so let us see what will happen if I am adding one bias. Okay, so I am cutting it. I am going to add one bias. That means I am going to add one input voltage source. Okay, positive, negative. I'm dragging it. I am giving a V reference value. The total voltage is 10 volt I have given. Let me change it to 3 volt V reference. Or some extra value also I can give. I am giving 7 volt. What will happen? You can see some small changes that are happening in the waveform now. Yes or no? The portions are here getting up now, moving up. Are you able to observe? If I reduce means it will move down. Okay, I am reducing now. 5 I am keeping. It will move down. If I am increasing means it will move up like that. You can observe. The positive portions will be extra if I am increasing the value of RPS. If I am reducing means it will go down, down, down. Okay. Understood? This is where I have given RPS 5 volt. If I am giving 8 volt means the portion will go up now. 8 I am giving. You can see. Are you able to observe now how much it is going up? This portion? Yes or no? The waveform will move up if I go on increasing the RPS. Okay? Understood or not? If I give 10 volt means there will be no clipping. Okay, if I give 10 volt means, well, let's see what happens. Full waveform will come like that. You can see the full waveform, full sinusoidal. Yes or no? Like this, full sinusoidal you are observing, no? Like that. Understood?
Yes, ma'am.
Okay.
Yes,
All
ma'am.
of you can try out with changing the value. It's your wish. Okay, so this is what type of clipper?
Biased
What type
clipper.
of clipper is this? Bias, positive or negative? Positive or negative? Which
Positive.
portions are clipped here? Positive portions. So this is a positive clipper. Okay. Next we will check out negative clipping. Negative clipping, how you will get? Simply you reverse the position of the diode. Okay. I will swap the terminal. See, I have reversed the diode. I have swapped the terminal. And the RPS also I have to swap the terminal. Okay. I have reversed both. Okay. Are you able to see now which portions are clipped? Okay, 4 volt. without RPS, what happens first? Something is wrong. I'll try out fresh. All are trying out these circuits? Yes or no?
Yes, ma'am.
I'll give 10 volts,
Yes, ma'am.
50, sorry, 50 hertz. I'm giving 20 volt here. 10K. Observing what is the input. And I'm observing what is the output. This is also showing a think there is some problem. It's not flipping negative. Let me see what happens if I add the RPS. See, instead of just checking view in scope, you add an analog out as I am doing. Okay, that way only you will be able to see the output. Now you are able to observe how the negative portions are clipped up. Because you have to see the waveforms across the entire series combination of diode and RPS. That is why the output came wrong. So here I have given V reference how much value? How much value I have given? V reference is how much value I have set here. All in class, or is there? 0. So this is like an unbiased clipper. So here what portions of the waveforms are clipped, as you can observe from the output, what portions is clipped? Negative portions are clipped or positive portion?
Negative.
Negative portions are clipped or positive portions are clipped?
Negative.
Negative.
So what type of clipper is this? This is a negative clipper or a positive clipper?
Negative clipper.
Negative. So suppose if I am making it a biased one, I am adding 5. Let us see what happens. So you can see the amplitude just grows. Yes or no?
Yes,
But in
ma'am.
the positive direction or negative direction? It is growing in the positive direction or negative direction? It is growing in the positive direction or negative direction? Upwards or downwards it's growing?
Upwards.
Upwards. Okay. Suppose if I reverse the terminal, I am swapping the terminal. Now let us see what happens. Now it is going downwards or upwards?
Down.
Downwards.
Okay, that is the reason for biasing. So now let me edit it, and I am increasing the value still some more value 10 I am giving. Let us see what happens. I will still go down, down, down and down. Okay. Understood now? This is all about what type of clipper?
Negative clip.
Negative.
Negative clipper. Biased clipper. Okay. One more thing, you add analog output like I am adding, you add. Otherwise the answers are not coming correct. So add the analog output like I am adding. Understood, huh?
For negative
Understood,
clip,
Amma?
ma'am.
Both positive clipper biased, negative clipper biased you have to do. With V reference 0 and one with V reference. Okay.
Yes, ma'am.
Alright. So for rectifier, 4 circuits, one half wave rectifier with the filter, without filter, full wave rectifier with the filter, without filter. For clamp clipper, positive clipper biased, unbiased. The negative clipper biased, unbiased. Okay. Understood? Understood or not?
Yes, ma'am.
Yes, ma'am.
Okay, for this I will keep some 10 days time I will give, okay? Because you have to finish so many circuits. No need to draw separate graphs. Whatever graphs you are obtaining underneath, you just copy and paste. That is enough, okay? No need to draw separate graphs. But whatever calculations that you have to fill up in the table, that you have to fill as per the formula for rectifier. Understood the instructions or not?
Ma'am, so we have to write it on from pen or in Word.
You have to write here afterwards. I won't ask you to do that Microsoft Word typing and all. I thought people will learn MS Word typing, so that's why I left you. I don't want to see the same copied matter. I am getting irritated seeing all you. So here afterwards you have to write everything in neat paper. Only the circuits you copy in Word along with the results, and you have to produce it. That's all. Okay. So with this we'll wind up the class now.
Can you repeat it again?
Yes, ma'am.
Ma'am, we will have to write the lab record material also.
Yes,
Like
everything you
the
have to
questions
write,
and
handwrite only, okay?
Ma'am,
You have to write title and whatever things are there in the first page, split up marks, split up you have to write. Then you have to write P-lab, then you have to write the theory, procedure, everything. Plus you have to draw the diagram, huh?
Ma'am, can you reduce the
Ma'am, please,
marks for
ma'am.
us, ma'am? As we are
I
having
don't want to give lenience to anybody, no matter whether you are telling anything, because I am getting irritated seeing everybody's, because there are 60 people there in the class. If I see to everybody, I will not know from who copied. I cannot punish anybody. I have to give benefit of doubt also. But I do see. I won't ask you to. Otherwise, you skip theory part. Okay, only circuit diagram you draw.
yes, yes,
Alright.
ma'am. Yes, ma'am. It
Skip
will
the
be
theory part, procedure and all you skip. Okay, only that first page
calculation and
title.
graph only.
Wait, title should be there, experiment number should be there, date should be there, mark split up should be there, pre-lab, post-lab questions should be there. Okay.
Okay.
Alright,
And procedure.
circuit diagram should be there and result should be there. And calculation, if there is calculation tabular column, you write. Okay, remaining thing you skip. Alright, all the theory matter, procedure and all you skip. Okay.
Yeah,
And
ma'am.
then you have to copy the circuits in a Word document and you have to paste it. Okay. And I think all are able to see the marks that I uploaded yesterday, your CT marks and lab marks, whoever completed all the 3 experiments. I have
Yes,
taken
ma'am.
the average for 3 and I have posted it. And I have told Om Raj that I am not able to open your document. Still, nothing has been done from your side. Don't blame me if you are getting 0 for your first lab component.
Ma'am,
Okay.
you want us to write the procedure?
Tejashwini, also you submitted only one experiment, huh?
Ma'am, I've submitted three actually. I've submitted all the three.
Ma'am, I
I
also
haven't submitted
submitted 3.
experiment for that.
Let me check again. But I will check
Ma'am,
again.
there is
Let
check
me
Ma'am,
mark.
see.
can
Oh
I
yes,
know
ma'am.
where my marks have been cut?
Who is speaking to me now?
Ma'am, Rajarshi.
Where my mark sheet? That means I have edited your document and you are able to see the edited document. You check out where I have cut marks, Rajshi.
Ma'am, in which experiment I mean?
You check out the edited document. Edited document are there for your observation. You can check it out. You can check in what I have reduced mark, na?
Ma'am, I have not got mark.
Very
Go to
well.
that, go to that mark split up and then you will know where ma'am has reduced your mark.
In GC.
Yes, I have written comments also there.
Yes,
Okay.
ma'am. We don't have to
What?
write the procedure. And the
See,
model-
here afterwards, like I am telling you, write in a neat A4 sheet, draw margin, you put experiment number, date, title, mark, split up, pre-lab question, post-lab question, then circuit diagram, tabular column and calculation part and result. Okay, these
Ma'am.
things you write it in a neat paper and submit. And as a separate document, you have to cut, copy, paste all the outputs along with the results neatly so that it is legible to me for me to check out the answers. Then only you will get full mark.
Ma'am, but we are doing experiments on our own, ma'am.
I don't care. Okay,
Ma'am, because the
for
format
one or two person in class who is perfect, I cannot.
Ma'am, but the format of the thing is just same, and the
I don't care, I told you no. As I told you, I don't want to see the same copied matter. I don't know who to give the benefit of doubt. So common instruction for everybody. Okay. For you, I am exempting not writing the write-up part. So be happy with that.
okay, ma'am.
It will be a practice only if you are drawing circuit diagram. For model practical, university practical and all, you have to do the same thing. Written work only you have to do. So better make it a practice. Circuit diagram and all, the more you practice drawing, you more you will remember.
Ma'am, can you repeat, ma'am? I was not able to hear.
First thing, first paper, experiment number, date and title, mark split up, then pre-lab, then the circuit diagrams, then model calculation, tabular column, then post-lab, result. That's all. Okay?
Ma'am, we have to withdraw
No need to write.
And also one more thing.
No need to write procedure.
Ma'am, one more thing was there. Will we have to submit this when we come to college, or can we do it
When
on
are you
separate
going to come to college, man? I don't know when that will happen. Next semester or the semester after next semester. They are not going to open
What
college
he's meaning
quickly.
is, no, ma'am,
Ma'am,
what
he
he's
is
meaning is
asked-
that should we keep record of all these or can we just, should we write
See,
all
for
in the
this
book or paper?
semester, you have to keep it separately. Okay, it will be good for from your side. If I ask doubt somewhere later, then you will be able to produce your document and get your doubts clarified, na? So for till the
No,
end
but
of the
everything
semester,
is
you
It
keep.
will be
copies
same
there,
in
ma'am.
GCR, no?
Ma'am,
But
You
but
put a separate folder with you. Okay, for this experiment,
ma'am,
and
you
Ma'am,
should,
line
ma'am,
pages
what
you
he's
put it in
asking
sequence.
is, do we need to keep the hard copy with us?
yeah,
That's what he's asking,
he's
ma'am.
asking
Hard
that.
copy, anyway you are making it a PDF document now. You should put it in
So
your
hard copy
computer.
is not needed, no, ma'am. Hard
Not
copy we don't
needed.
need, ma'am.
No
Okay,
need.
okay.
Anyway, you are
Only
making
soft
it a
copy.
PDF copy. Okay, only soft
Okay,
copy.
Okay, ma'am.
And
Ma'am,
miss,
our lined pages will be all right now.
Yeah, PDF copy you put it. That's all. Okay.
We have to do this after from experiment 4.
no,
Just from demo of DC machine. Next experiment that you are to submit is demo of DC and AC machine. That you have to
Ma'am, I
write
had
it.
completed it, ma'am.